In this video, we're going to learn how to apply our knowledge of rational equations to work-related problems. So the work rate problems we're going to look at in this lesson use the general format below. And it's basically stating that if a person does job A in time A, so say for example, Tim can clean the house in 4 hours by himself. That would be 1/4 because that's Tim's time. Plus, then say we have a second person can do a job in time B. So say we have Candace, and she can do that same job of cleaning the house by herself in 3 hours. So that would be 1/3. Then together they can do their job in time T. So that's 1/, in this case, we don't know what it is, we're trying to find it, so I'm going to put X because I don't know how long it's going to take. But we can actually set up a work-related problem if we know different pieces of information. So if we know at least 2 of these, we can find, how long it would take them to do the job in total if they worked together, how long it would take them if they worked separately, things like that. We're going to use this general equation here, 1/person A's time alone, 1/person B time alone, equals 1/ their total time it would take them to complete a job. So let's jump in and try this first example. So here we see that you are cleaning the house with your sibling, and if you were to clean the house by yourself, it would take 4 hours. If your sibling were to clean the house by themselves, it would take them 5 hours. If you work together, how quickly can you clean the house? So we know we're going to use this general 1/A, 1/B, where A and B represent the time it would take us each to do the job alone, and we're going to look for our total time as a team. So here, I would take 4 hours, so it would be 1/4, plus my sibling would take 5 hours, so it would be 1/5, and I want to figure out what the total amount of time would be for us to do that job together. Now, I can leave it as T. I'm going to turn it into X just because I like using the variable X a little bit better, but it's completely up to you. So here we're looking for how long does it take us to do this job together, and we're going to need to use our knowledge of rational equation solving. Now here we know that in order to solve a rational equation, we need to get common denominators across the board. So if I look here, I notice I have a denominator of 4, a denominator of 5, and a denominator of X. So if I'm going to shoot for a common denominator, it's going to have to be 4 times 5, which is 20, along with the X. So I need to make each common denominator 20X. So in this case of this first problem, I'm going to multiply the first fraction by 5, and I'm going to multiply it by X, because that will encompass the 2 missing pieces of the denominator that I currently don't have. So if I do this, I end up with 5X over 20X. Then from here, I look at fraction 2, and to make that 20, I need to multiply it by 4. And then I also need to multiply it by X to get the X piece. So here this becomes 4X over 20X. Then from here, I need to turn this one into a 20X, so I'm going to multiply it by 4 and 5, which is really just multiplying it by 20. But I end up with 20 in my numerator over 20X in my denominator. So notice that I've used my rational equation solving strategy of getting common denominators to start this process. Now because I have common denominators, I can simply set all of the numerators, 5X plus 4X equals 20, up as an equation. So I'm going to do that. So I have 5X plus 4X is equal to 20. So now if I solve this little equation, I end up with 9X is equal to 20. And then if I divide 20 by 9 to get the X alone, I find X is equal to 2.22. Well, this actually represents the number of hours that it would take us to do this job together. So if my sibling and I were to complete this job together, it would take us 2.22 hours, which if you think about the situation, given I can do it in 4 and my sibling can do it in 5, 2.22 hours sounds about right. So let's take a look at this second example here. This example says that Jack and Jane are working together to finish their yard work. If Jack were to do the yard work by himself, it would take him X hours. So what we're noticing here is we don't actually know how many hours it would take Jack. We're using a variable to represent that. So let's make a note that X equals the number of hours it will take Jack. And this is something we're probably going to have to find later on. Then it says if Jane were to complete the work by herself, it would take her 3 more hours than Jack. So while this seems like it's not maybe super helpful, we can actually figure out that Jane's hours can also be represented using that X value. So Jane's hours, we take 3 hours more than Jack. Well, if Jack represents X, Jane has to represent whatever X is plus 3 because she takes 3 hours longer to do the same amount of work. So here we know that Jack takes X hours and Jane takes whatever X is plus 3 hours. We also know that when they work together, they can complete the work in 12 hours. So 12 is how long they can complete the work together. So we're going to use the same equation of 1 over A plus 1 over B equals 1 over T, but we're going to use these values instead. So we have variables that are a little bit more present in the problem. So 1 over A, that's going to represent Jack. So we have 1 over X plus Jane is 1 over X plus 3 because she takes 3 more hours than Jack. And then total, it's 1 over their total number of hours, which is 12. So here I'm going to have to find a common denominator again in order to help me solve this. So here my common denominator is going to have to contain the X of the first fraction, the X plus 3 of the second fraction, and then the 12 of the third fraction. So my common denominator is going to look something like that. So I'm going to start with this first one. It might take me a little bit more work on this problem, but I'm going to multiply it by the X plus 3. So if I make a little note, this being the 1 distributes, but it just becomes X plus 3 over X times X plus 3. And then I'm going to multiply it by the 12 and make sure I distribute the 12. So that becomes 12X plus 36 over that common denominator of 12X times X plus 3. So I've manipulated my first fraction here to match. Now if I look at the second one, I notice that this one has the X plus 3 but needs the 12X. So I'm just going to multiply it by 12X right off the bat. So that's pretty simple to do. So here we have a 12X in our numerator, and then we have 12X times X plus 3 in our denominator. Now this last one's going to take a little bit more work here. So here I need to multiply the 12 by X, which is pretty easy to do at first. So I'm going to multiply the numerator by X. So I end up with X over 12X. And then I need to multiply by that denominator, which is going to be X plus 3. So my numerator, if I distribute, becomes X squared plus 3X all over, we have our common denominator of 12X times X plus 3. So I'm going to bring this middle one down a little bit so I can see exactly what I have right now. So here I have everything written with a common denominator, and because of that, I can now turn this into an equation that just utilizes the numerator part. So I'm going to bring that up here. So here I have 12X plus 36 plus 12X equals X squared plus 3X. So now I need to solve this, and because I have an X squared, I know that I'm going to be solving this with a quadratic. So I'm going to start by getting everything onto the same side as the X squared. And so here I notice, okay, I have 12X and 12X, so that's 24X. So I'm going to subtract 24X from each side, and then I'm going to subtract 36. from each side. So I end up with 0 equals x squared plus 3x, which then I subtract the 24x from, so that becomes a negative 21x minus 36. So now let's just use our quadratic formula here to solve this quadratic. So we have x equals negative b, so 21 plus or minus the square root of negative 21 squared minus 4 times 1 times negative 36, all over 2 times a, which is 1. So if we do the square root part, we have negative 21 squared minus 4 times 1 times negative 36. So that becomes 21 plus or minus the square root of 585 over 2. If we square root 585, we find that that's 21 plus or minus 24.19, all divided by 2. Need a little more space here. So then we take 21 plus 24.19, divide that by 2. So I find one option for x is that x equals 22.595, or that x is equal to, if I take 21 minus 24.19, x is equal to negative 1.595. Now if you think about this, that really doesn't make sense to have a negative 1, so we can cross that off and just focus on the positive answer. So what it's looking like is, it looks like my x value is going to be equal to about 22.6 hours, which would mean it would take Jack 22.6 hours, and it would take Jane a little bit longer than that. So if we have x is 22.6 hours, that is saying Jack takes 22.6 hours, and then Jane takes 3 more hours than that, so that would be 25.6 hours. Now, if you think that this doesn't look quite correct, you can check it. And you can say, okay, well, my equation that should work is 1 over A plus 1 over B equals 1 over C. Well, let's check this. 1 over 22.6 plus 1 over 25.6. So if we take that, we find that that equals approximately 0.083. And then if we take 1 over 12, we find that that also equals 0.083. So we have in fact found the correct number of hours it would take Jack and Jane to complete that same work by themselves if they didn't work together. And finally, one last example here of items that are working against each other. So here it says a rain gutter can fill a bucket in approximately 8 hours. So this rain bucket working by itself fills it in 8 hours. So that's probably going to be our 1 over A. If the spigot on the barrel is open, the barrel will drain in 14 hours. So draining is telling me that this is going to be working against the bucket. So they're not going to be working together, they're going to be working against each other. But this is what I'm probably going to use for 1 over B. And if the spigot is left open during a rainstorm, how long will it take the barrel to be full? So if we think about this barrel here, it's got a rain gutter feeding into it with water coming in, so it's filling up. But then it's got a spigot open over here and there's water coming out. So what's happening is there's water coming in more quickly than water is going out, but there's still some water draining. So we're anticipating it's going to take more than 8 hours to fill that bucket because there's water coming in at a fast rate, but then it's leaving as well. So here, instead of it being a plus sign because they're working together, if we're working against each other, we're going to use subtraction. So here we're going to have 1 over A, which is what's helping fill the bucket, and we're going to subtract out what's emptying the bucket and find how long that's going to take in total. So this one is a little bit different because they are working against each other. So here if we set this up, we have 1 over 8 is how long it takes the rain gutter to fill the bucket. Then we're going to subtract out the 1 over 14, which is the spigot releasing water out the other side. And we want to find the total amount of time that takes, which is 1 over x. So here we need to find a common denominator. Now I don't know a lot of numbers that both 14 and 8 go into, so I'm just going to multiply 14 and 8 together. to find that my common denominator is going to probably be 112x. So that's going to be my goal, to get each of them to be 112x. So if I multiply this first fraction here by 14x, I end up with 14x over 112x. If I multiply the second one by 8x, I end up with minus 8x over 112x. And that equals, we're going to do 112 times this one, 112 over 112x. So just by getting that common denominator, I can now eliminate the denominators and set this up to be 14x minus 8x is equal to 112. So now if I combine like terms, I have 6x is equal to 112. Divide both sides by 6, and I find that as they work against each other, now it's going to take approximately 18.67 hours for that rain bucket to be completely filled. So we've got this rain bucket that is being filled, the water's coming in, but it's also going out, and because these two items are working against each other, it's going to take a little bit longer for it to actually fill.